This next video is about question 5a, which seems like a impossible question to begin with. They want you to find all the values of x in the domain from 0 to pi, such that sine x equals to cos 5x. Now I've written the question again up here, just so you can see it a bit easier. The thing about this question is that you cannot just trial and error your way through finding all the values of x. It's impossible to get all the values of x using this method. So what you need to do is you need to organize yourself by first using a trig identity, such as the fact that sine of x equals to cos of pi on 2 minus x, or one of the other ones on the 5x. As you can see, there are two paths you can go. You can either try to make everything a sine or everything a cos. Okay? And in each of these paths, you can either go, maybe do the pi on 2 minus 5x like that, or you can go here and change that into cos pi on 2 minus x. Now, which one would you choose? And more importantly, in each of these paths, the next step is you can either go, right, pi on 2 minus 5x. If you think about it, x is one of the angles that will equals to this. Well, surprisingly, so is sine of 2 pi plus x, or any other revolution of x. I mean, x is a particular solution. This is a good word to use to describe what x is in this case. It's a particular solution to sine of something unknown equals to sine of that particular solution. So what actually happens is that gets featured in the general solution using sine, which is pi on 2 minus 5x times pi n, and so on. Now, you could, of course, make x the subject and call this one the particular solution like this, and have this other option. Similarly, over here, you can either have 5x as the particular solution here, or you can have this as the particular solution here. Now, it comes down to which one of these four do you choose to work with, because all of them will eventually give you the same answers, but some of them takes a bit more working out or slightly more confusing equations work, because you're going to get more negatives more often. Well, in our case, we chose this one. Now, before moving on, you can obviously just have a look at how this question will pan out. What will happen is you're obviously going to be substituting a whole set of values of n equals 0, n equals to 1, and figuring out what the plus minus will do in terms of finding what x is. So if I substituted n equals 0, I solved x to be this one. Now this one fits in the domain just fine, so we have a little tick next to it. This one doesn't, because this one's less than 0, so we don't want that. Same thing for 1. But you can see, notice how, just to be careful, I've just decided to try n equals to -1 just to see if we can get any more valid solutions, and none of these are going to give you a value of x that's greater than 0, so we don't care about any of these. Then go to n equals to 1, yes, yep, n equals to 2, correct, correct. Notice how the values are getting closer to pi, so when you get to n equals to 3, that's when you realize, okay, we got 13 pi on 12, too big, and 11 pi on 8, too big. So we ended up with 5 solutions. Pi on 12, 5 pi on 12, 3 pi on 8, 9 pi on 12, and 7 pi on 8. Now that would not have been easy to do by just trial and error of the original equation. In fact, this is the only recommended way of doing this question. Of course, you could have tried the other path and gotten the same answers. It would just have slightly different looking working out.